$4,200 in 63 hours. An agent running on its own caused this much amount of bills. Nothing was wrong, no alarms was fired, no one made any mistake. Still this happened. And this is not a hypothetical story, this is the real situations. Just because someone miss a arithmetic calculation. So this is the part you should be most concerned about before designing any agentic system. You should know its boundary. You should do some mathematical calculations, just like we did in normal system, right? And also this will help you in interview when you are designing agentic system. When you do the calculation, this will help you to take certain decisions which was otherwise you might have forget, or you might not take into the consideration. So yeah, welcome to the Agentic System Design episode 7. This is the first episode of part 2 engineering sections, where we will deep dive on a specific topic in more depth. And first one is we are starting with the back of envelope calculations. This is really important. We do a lot in system design normal, but this will be more focused about how we will do that into agentic system design, right? So let's move further and see the magic of it. So what does one run actually cost, right? So this is the main questions, like whenever we are doing like design, the main things we'll mind, what does one run actually cost, right? So we'll move and see how it happens. So there are 3 tiers in like any agentic system, as I explained before in our chapter. First tier is basically the client. So if you see, like if you use ChatGPT on web, you open ChatGPT website, or if you're using cloud, you open cloud app, or you're using like cloud in your terminal or anything. So that first thing is client, where actually user is interacting. And the second thing is orchestration servers. So whenever you are typing something on ChatGPT, it is not directly going to the ChatGPT OpenAI actual LLM. It is going to the OpenAI servers in the cloud, and those servers are doing some kind of processing. We will know much about, like in the later upcoming episode, like what processing they are doing. And then those servers are basically calling to the LLM, and LLM is doing the response and returning back, right? So when we'll talk about basically the here the calculation part of it, we will not talk about much on client because it's not needed. Orchestration server, yes, we will talk little bit. Again, it's not very important because that's very predictable. We will need it when we are scaling our service. So I will talk briefly about it, like what is the parameter we need to consider and why. But the important part is the LLM, which, because we are designing agentic system and this is the new, so we will talk about it because most of your bills will go into LLM, like 90% of bills. So and the good little surprise thing is here is this bill is not linear. It can also surprise you, and as well as how you are planning things can also detect matter how your performance is coming. So there are more to it. So we'll deep dive into this section more here, right? So let's see, when we are monitoring any LLM or when we are doing calculations for any LLM, right? There are 5 axes we need to figure it out, right? So I will just give a summary and then we will go and explain much. First, about the token. So how actually you pay for it? Because if you see, you might take like 20 pounds subscription or 100 pound subscription of OpenAI or Anthropic, and you say, okay, Sunny, I'm done. I can use how much I want. But it's not true. That's a consumer specific subscription. But when you go and build your actual agentic system, which will call their API, they will charge, and no one kind of make a consumer or some like plans where you can spend a certain amount and get like unlimited subscription. No, so there you have to pay per API basis, right? For even if you're going Anthropic, Gemini, or OpenAI. So that's like how much token you are spending, which means how much money you are spending on your agents. That's matter because that's how you can predict your bills and you can plan like you can take decision based on your budget, right? Next thing is subtask. So basically like whenever we are designing an agent, like even if you're designing a workflow, agentic system workflow, I'm not talking about agent. I told you differences like in agent, we have a loop which keep repeating until you are getting an output. But in a workflow, you have a predictable stage. But inside the workflow also, there might be like multiple steps, right? So we also have to like calculate about how many subtasks are and what it will impact on bills, right? Next thing is retries. So yes, we will have like retries on failure because we are working in a distributed system. There are multiple choke points. For example, there may be throughput choke point, or your actually the orchestration server is performing something low, and things can go wrong. So in that case, you will do retries, right? So how much retry you calculated, based on that, we will also consider that into our calculations, because in a computer science, when you design something, you just don't design for the like best case scenario, design for the worst case scenario, right? So how we will calculate it will come later. Next is latency. So this is important. Every LLM call has a latency. So what is your system latency, and how much you can tolerate, and also based on this we will take a design decision like how our system should look like. We'll talk more about in detail section. And next is context window. This is like very important. If you are not managing this context window, your LLM will start hallucinating and giving you like the just random response, right? So how to manage it, how to calculate it, we will talk like in just upcoming few seconds. Okay, so yeah, let's talk about the token first. So what are the tokens? So tokens are like the smallest like unit which LLM can understand. Just for the context, token is not word. For example, if you see agentic system design, it has 3 words. It doesn't mean it has 3 tokens. So token usually kind of content 4 byte, and every LLM provider has their own mechanism of like tokenizing things the way they train their model. So what happening is like they give you the free tokenizer library. For example, Anthropic also give, OpenAI also give. You can pass a prompt to that library, and it will exactly tell you like how much token you are consuming, right? So what will happen is all the API pricing we are seeing is basically based on token. Like per million token, you have to pay a certain amount, like $3, $4, based on like which model you are using, right? So roughly how we will calculate. For example, let's talk about the AI digest thing, right? So we are processing an article, and considering like one article will take around 3,000 tokens. Like based on the word size, I just put a number here, and every time we are processing, like we are making a call with in like that much context. When I say context, it's also like 3,000 tokens contain my prompt and my articles and everything, right? So let's start with this. So what will happen is 3,000 tokens per call I'm spending, and this is like a Sonnet, Anthropic Sonnet charge £3 per million token, right? So if we see, it will come around a three. If we do so if we do some calculation like 3,000 by 1 million into 3, it will be like 9 cents per call. So this is like what I'm gonna spend on every single call. So this is like one things in mind, right? Next is like subtask. So we did calculate the token in the previous one, but that is for one call and in one agentic system. I'm not saying like in actual agents. Even if we are designing a workflow, that's also agentic system. In workflow, like rounds are predictable, but there could be like multiple LLM call. For example, in agentic system design, we will have like one for fetch call, one for rank call, one for summarize, one for archive, which means like you will fetch the article, you will rank them, and then you will summarize them, and you will archive them, right? Whether which one we are picking it, right? So there are like 4 steps involved here. So I'm assuming like we will put a limit of like 100 article per day into 4 tasks. So total will be like 400 calls we have to make in a day. Like I'm saying like we will do like one run in a day, right? And then 400 cross 3,000 tokens, which we calculate early, it will be like 1.2 million token we have to spend per day. And if we do the math, it will be around 360 pound per day if I'm running per day, and around 108 dollar I need to spend monthly, right? So see this how this matters. Since I'm building a demo project, maybe I will switch the running to from daily to maybe weekly, because obviously like I don't want to spend 108 pound per month. And also there could be like multiple optimizations happen here. For example, rather than fetching like 100 article, I can focus like I will just fetch top 50 article, right? So if you do these calculations, you can take better decisions. And when I say better decisions are not like right or wrong. It's basically based on your situations, right? So for example, if you're a big corporations which don't care about money, they really don't bother about like bills, right? You can literally go running every hours or every six hours or so on. You can increase the article size, but based on like whatever your requirement, whatever your budget, and what is your scale, you can tweak these calculations, and you can see like what the projected figure look like, and that will really help you to take decisions like where to go. So again, nothing is right or wrong. It's depending upon your requirement, your custom situation. So but if you're doing a calculations, you can see where you are going through, and you can adjust the requirement, adjust basically your system. Okay, so let's talk about the retries. So the last 2 are linear, which means like if you increase the number of calls, the price will increase. But retries are not linear because the retries came like if something failed, right? Yeah, so basically this is interesting. If you can say like, okay, we are making 80% success rate, and then we are making 3 retries. So worst case we can go like 3 times, right? Which is correct, but we will not calculate the worst case. We will calculate here all the cases, and we'll see. So yes, you are right. For the worst case scenario, we can go 3x, and best case scenario, we can go like just one time call pass. But what is the mean run? So if we see about the probability, so first time, for example, so okay, I directly put the number, but let's see how it's coming here. So first time the probability here is like 80%. So the probability of failing is 20%, which means like 0.2. But if you go further, if you're making a second call, the probability of failing the second call is again 80%. Like passing 80% and failing is 20%. But if you combine both, the probability will go more down. So probability of, if you combine both, probability of failing in a second call will become 0.04. And again, if you go further, third call, and individual call probability is failing is 20%. But if you combine 3 as a system, probability will go again further for that specific third call in with respect to all system to like 0.008. And if you just combine all 3, overall probability of like failing or mean like going through all the retries is 0.1, 0.25, and after taking the buffer, I took like 1.95. So that is like an average attempts we are going, right? So yeah, 5% might goes wrong. So here if we calculate, it will give you a range. Like normal we are spending happy path 3.6 pound, but on an average we will spend 7 pound, and a bad day will spend like 11. So again, when we are calculating this, we will not do like an exact things, but you should have a rough figure like how much it goes. It's like we will target like, okay, we are spending 7 pound in a normal days, but we will know that it can max go till like 11. So that is give you an idea, right? So let's talk about the latency. That's a very interesting things. Okay, so what latency is, like how much time it is taking for your request to reply, right? And latency is not something just one number. It can vary. Like few of your request will be like faster, and few of them will be like really taking long time, right? So if you see, when we calculate the latency, we calculate based we use some metrics like P50, P90, P80, something like that. What P pays the P50 or P99 means. So when we say P50, which means your 50% of request is facing this much latency, or in another way you can say 50% of your request will go higher than this. If you see here in the screen, our P50 is somewhere around 2 seconds, right? Which means like all our 50% request is passing within 2 seconds, or 50% request passing after 2 seconds, right? And if you go P99, which is somewhere around 15 seconds, right? Which means like all our 99% of requests are passing within 15 seconds, or in another way we can see there are 1% requests which are taking more than 15 seconds. So that is like important. And when we are planning, we will plan for that P59 like P99. So when we're doing a demo, it's run on like this is just a classic dialogue I put. It's run on P50 because this is like an average case, best case. But when the P99 things will give you like support tickets where some request fail, because once you cross like this P99, which means like more than 15 seconds, you will start facing timeout, and there will be much problem happening, and you will start getting tickets. So we have to see about this P99 more, and we have to like plan for it, right? So for example, if your P50 is like 2 seconds and P99 is 15 to 20 seconds, like it's include retries and everything. So we will plan for P99, not for the P50. Okay. Next thing is we'll talk about the context, and this is like very important. So what this context window is, so if you see, like whenever we make a call to the LLM, actually LLM is stateless. Okay, this is a very beautiful architecture. So LLM does not contain any state of your call. So when we are making a request, all of your context goes with the request. You can think it as a request body in a normal REST call, right? And then LLM process your request with those contexts and give you the reply. Which means if you're talking to your like ChatGPT, for example, all your calls, like all your chats, like a different message, maybe or maybe are replied by it servers, different servers running at a different scale. And this is the beauty. That's why they can scale this LLM things super fast. If you see like Anthropic acquire whole SpaceX data center, and within days like they scale it and start giving everyone more limit. How they do it? Because all they have to do is they have to just scale their LLM, deploy it there, and LLM are stateless. They are not actually storing any state, which means any call coming to the one LLM can go to another LLM without any worry, because the whole magic is into the context. Because whenever we are calling the LLM, we are calling the LLM with the context, and when we say context is containing all your current prompt as well as the history of the prompt, which means every time you are chatting with the LLM, or we are proceeding with the LLM in future, your context will keep growing because it's contain your current prompt and also contain your previous prompt. And the problem is every model has a hard context limit. When I say context limit, that's like how much context they can process, or how much like you can say the request body they can accept, right? And if you breach that context limit, what will happen is model will randomly drop your previous context, and it will give you incorrect output, or it will start giving you which you can say like it will start hallucinating, right? So that's why if you see you heard about if you're using Cloud Code or any VS Code extension, you see a context is running on, and after a certain time it's a context overflow, and it summarize it and it start again, right? So how much context it is? So normal Sonnet one provide like 200k context, like 200k tokens. But there are like advanced model like Opus 4.7 or like even OpenAI also launched, which also contain like 1 million context, right? Which means like you can send 1 million token with the API call, and they can handle it, which means like they can handle more data, and they can give you more response, right? But again, not every time we are going to use like 1 million token model, because that is cost you more. So we should know what the context limit is. So for example, how to calculate the context. So whenever your context is growing, we will calculate it, how much we consume it, and we will plan for like 60% if whatever the 60% went. And then after the 60% context you consume, what you have to do is you have to take some actions, either drop the context or summarize the context, or if you cannot, like the thing with summarization is like with the time it will also kind of bloat it. So what happening is, for example, you chatted and you put like this much of data which consume like 60% of your context. Then you summarize it. You summarize like this into like little bit of detail, and then with the next request you are sending this summarization, and again you are starting your chatting again, or like history again, and again you summarize and you put it again. So if you do it for like, for example, 5, 6, 10 different turn, right, you will see like even your compressed context is consuming more than 50% of bandwidth. So that is again a problem. So how we'll solve it? Then the rack came where you store your context into local and do. So there are like optimization thing we will learn when actually we will learn about those skill into our system design. But the main context here is we need to calculate how much context we are consuming, and it will impact our design decision. For example, in AI System Digest, we know that if we are using Sonnet model, there is 200k tokens. So how much article max we can send to the LLM will have a limit. Like we should not want to exhaust like 100% of context. And again, we should take some buffer, because when you are sending some prompt, you also designing an agentic system, you also send some system prompt, right? So this way we can decide. We will not just fetch like thousands like article or like 10,000 articles and just dump it to the LLM. It will blow, right? So yeah. So now you see how these things are relating. So what is the requirement? Do you want to fetch like 1,000 articles? Then maybe you need to change your LLM. Maybe you need to go with like 1 million context window. Again, 1 million has a limit, 1 million, right? If you're again extending that, then which means you cannot simply send it. You need to look for some context solution, right? So if you're doing this calculation, this will help you to decide which action to take or which where to go. And this is very important as a senior engineer, or especially in the interview, because they will look for it like whatever your design decisions are basically calculated on this like parameters or not. In interview, they usually push a boundary and they expect you to find it and tune your design based on that, right? So you see context window calculation is like very important, right? Again, how you will calculate it? You have a tokenizer library, pass all your prompt there, and simply it will give you the token, like how much token your context is, and you can put a limit. And once you hit like certain, you do some actions. We'll talk about that later. Okay. So next thing is like orchestration box, which is like an actual server. If I say like we talk about the LLM, we talk about what LLM, how its size is. Next, we'll talk about the actual server, which is like taking the first request from the client. Again, I will not go further here because those are very much predictable, and it is like just we do in traditional system. For example, concurrency, we need to see like how much request your service is handling. So simply, if you are using like cloud providers, you can configure like if you're hitting this much concurrency, like what is the scale of your system? Like if you're designing something like ChatGPT where like millions and millions people are using, so you need to have like more of those orchestration server. If you're using like if you're designing a small system, you can have like a small server. So basically this will help you design like how much capacity you will need, right? And again, like how many CPU you will need, or the queue depth. For example, you are for example, your server is basically having some fixed concurrency limit, which means like this much many requests it can handle. So you will also attach a queue to not basically lost any conversation or any request. So what is the queue depth will look like, and what is the state store? For example, with every conversation you are storing some context in your server. Also, it has some RAM or some local memory. So we need to make sure that we are not breaching that limit. For example, if your memory is having like 24 GB in your servers, and you are storing too much context, which means like context of like maybe 512 MB for one chat. So you can say like maximum you can handle here is it will go around 48 requests, right? Maybe your concurrency is more than 48, but you hit the limit of memory. If you're going more than 48, you will again stop dropping the conversations, right? So these are the things we need to calculate. Same is like egress point. So you will get choked when you are defining a server. What egress means, like how much request or payload can come in and go out. So usually like if you're taking a servers, it has a limit how much bandwidth it can go in, go out. So even if you have a very good concurrency, even if you have a very good memory, but if your ingress is like choked, you will again start facing latency and timeout, right? So we should just keep that into mind. This is a traditional calculation. There is no surprises here because these are very linear, but these are the things we need to keep in mind. And one thing we need to see, like whatever the TPM is there. For example, if you're using AI like Bedrock or something, right? So they have like how much token per minute per account you can actually call, right? So we have to just keep that into mind so that our system is scaled based on our requirement. Otherwise, what will happen is, even if you have like a bigger model, even if you have like a bigger concurrency or bigger things, but if you're choking on any one of these parameters, your system will start giving you like timeout and latency, and you will feel like, okay, I have a like biggest model, everything, and why happening. So these are mostly will not surprise into the cost, but this will create bottleneck into the system, which will kind of outrun the benefit you are getting from a bigger model. So we have to just keep this into the mind. Okay. So yeah, what happened if you miss the or skip the math? So I give you the example, like someone run the autonomous coding agent, and they left it, and in 63 hours it cost like 4,200 pound. What happening is like there was some like planning agent, so and there was a retry, so it was planning agent sending request to the tools calling one, and it was doing retry, and it basically caught into the loop, and there was no control of breaking that loop, and eventually it, like OpenAI charged them like 4,200, and that's like really surprising. So how we will actually like control this? So I talk about what the parameter we are discussing right now, and then in the further episode we will also have like a proper lectures of like how we will control, so that we will not get any surprises, right? We'll talk about it later. So one rule before going, you should always plan for the tail, not for the mean, which means like you should always plan for the worst case scenario. Like you should not just plan for the best case scenario, like what worst case can you do, and that will give you like some protection against surprises, right? So that's the one rule you can take before going, right? So I will quickly summarize everything in the last. So there are three type tier architecture. One is client, one is orchestration, one is LLM. Okay, and LLM we will do like 5 type of calculations. One is token, one is subtask, one is retry, and latency, and the context window. And why all this important, I explain it. And there are like retries and context are basically non-linear, which means the retry will kind of with every calls the probability will reduce, and same way context, with every call it will increase. So for example, with every conversation goes, the context will increase. So we have to keep in mind. And then the rule, we have to plan for the worst case, not for the mean case, right? So yeah, this is a overall recap. So next question is, you size the math. So now you basically write the calculations. Now write the contract. So what the contract is, you do all the calculations, but you need to write it into a doc. You need to do a design, right? So if you're designing this system into in an actual team, right? So before actually implementing, writing any code, you need to write a design doc, like to explain it to your teammates, right, or your senior engineers for review. So next episode we'll talk about how to write a proper design doc for agentic system. Okay, so see you in the next episode. Till then, thank you. Bye bye.